Okay, so today we were talking about the different properties of addition and multiplication. So I've got our two notes pages side by side because I want to talk about some of the similarities that I see between these two. So on the left, we have our addition properties. On the right, we've got our multiplication properties. Now, one of the first things that I notice is that my multiplication has more properties than my addition does. But when I look at the properties of addition, so I have my commutative property, my associative property, my identity property, I also see the same thing over here on the multiplication side. So they share those properties, and we'll talk more about those in just a second. But then the multiplication has two special ones all to its own. It also has a zero property and a distributive property. So what I'm going to do is I'm going to start with the addition properties. We're going to talk about how they work with addition and then look and see how they are the same, how they are similar for multiplication. So I'm going to zoom myself in and we're going to start with the commutative property of addition. Okay, maybe if my camera will unzoom. There we go. All right, so the commutative property states that if the order of the addends change, okay, let's talk about what an addend is. You've heard this word before in elementary school, but it's been a whole summer, so let's talk about it. Addends are the numbers that you add together. So for example, in the addition problem 2 plus 3, my addends are the numbers 2 and 3. I also just realized I put an S there. Didn't need that. All right, so commutative property states if the order of the addends change, then the sum, which is the answer of an addition problem, should stay the same. And I don't know about you guys, but definitions, I don't really grasp them until I see them in action. So let's look at what this commutative property looks like when it comes to addition. So let's say I give us the example problem of 7 plus 2. Okay, if you were to see this sitting in front of you, I hope that all of you guys would say, oh yeah, Miss Smith, 7 plus 2 gives me an answer of 9. And let's look at how the commutative property would work here. So again, it says if the order of the addends change. So my addends here are the numbers 7 and 2. So let's change the order. Let's put the 2 first and the 7 second. So we've changed the order of the addends, but the sum should stay the same. So let's pretend this problem didn't exist. And I just have the problem 2 plus 7. Hopefully you guys would still all tell me that the answer is 9. So we've proved our commutative property. We flip-flopped the order of our addends, but we still got the same sum, the same answer of 9. So let's talk about the commutative property, but this time of multiplication. So when we look here, and I did make a mistake on my notes, but I fixed it. When we look at our definitions here, they look very, very similar. It starts with if the blank. Okay, so commutative property, it's still all about the order. But I don't have addends when I multiply. Instead, we call those numbers factors. And factors are the numbers that we are multiplying. So if the order of the factors change, then the product, that's what we call the answer to a multiplication problem, the product should stay the same. So it sounds very similar to the commutative property of adding, but multiplying this time. We have factors, we have a product. So again, let's see this in action. So if I gave us the problem 4 times 7. If I gave you this problem, hopefully you would say, oh yeah, Miss Smith, the answer to this problem of 4 times 7 is 28. So let's check the commutative property in action. So again, I'm going to change the order of the factors. So instead of 4 first, this time I'm going to put 7 first. So 7 times 4, but my product should stay the same. So 7 times 4 still gives me an answer of 28. So we switch the order of the factors, but our product remained the same. So that's our commutative property. It's all about order. So I'm going to switch back to addition, and this time let's talk about the associative property. So the associative property states that if the grouping of the addends change, then the sum stays the same. So it sounds very similar to commutative, but when we talked about commutative, that was all about order. Associative is all about grouping. So again, let's see this in action. So if I gave us the problem, let's say 4 plus, and then I'm going to use some parentheses, 7 plus 2, end parentheses, okay? All the ways we can see grouping are we can use parentheses or we can use brackets. And our order of operations always tells us to take care of the grouping first. So in this problem, I would need to solve 7 plus 2 first. So 7 plus 2 gives me 9, plus 4 for a final answer of 13. So the associative property in action says that if we change the grouping, our sum should still stay the same. So in this first problem, we grouped 7 and 2 together. This time, let's try grouping 4 and 7 together. So I have in parentheses 4 plus 7 on the outside of parentheses plus 2, and let's solve. So first step that I would need to solve would be 4 plus 7, which gives me 11, plus 2 for a final answer of 13. So sure enough, we changed the grouping, but we still got the same sum. So let's see what this looks like when we multiply. Let's see if I can get this to fit. There we go. Okay, so again, looks very similar. The associative property, it's still all about the grouping. So again, that includes our parentheses and brackets. So if the grouping of the factors change, then the product should stay the same. All right, to see the associative property in action, let me not make up some hard numbers. Let's do this. Let's do 2 times parentheses 6 times 3 in parentheses. Now, this is something we're going to get used to seeing. Instead of using the traditional X multiplication sign, excuse me, we can also represent multiplication by putting a dot in between our two numbers. Okay, so following order of operations, first step I would need to do is 6 times 3, which gives me 18, times 2 for a final answer of 36. Let's follow the associative property and let's change up the grouping. This time I'm going to group 2 and 6 together in parentheses, 3 on the outside, and let's solve. 2 times 6 would give me 12, times 3 for a final answer of 36. So again, we've changed up the order of we've changed up the grouping of our factors, but we still ended up with the same final product. So associative is all about grouping. Commutative is all about order. Let's talk about the identity property. I'm going to start with the addition. So our identity property of addition states that, again, the sum of any number and 0 is that number. Okay, so what this would look like is we have to keep the identity of the number the same. So if I were to do 14 plus 0, I would get an answer of 14. So I have any number and 0, and the sum is the number that I started with. So I could do 0 plus 8. There's 0. There's any number. The sum is going to be that number, 8. I could do 11 plus 0. Again, I have a number plus 0, and my answer is just that number. So there's our identity property of addition. Let's talk about our identity property of multiplication. Kind of changes here a little bit. So the identity property of multiplication states that the product, because again, that's the answer to a multiplication problem, the product of any number and 1 is that number. So there's our first big difference here. It's kind of stayed the same up until now, but identity for adding is 0. Identity for multiplication is 1. So I could do 14 times 1, and I'd get an answer of 14. I could do 12 times 1 and get an answer of 12. I could do 6 times 1 and get an answer of 6. Okay, again, the product of any number and 1 is just that number. Okay, so there is our identity properties. Now here's where multiplication gets special. It has 2 extra properties. It has the 0 property and the distributive property. So let's talk about the 0 property. So the 0 property states that the product of any number and 0 is 0. So when I multiply any number, let's say I have the number 9, and I multiply it times 0, I will always get an answer of 0. I could pick an even bigger number, like 173. But if I multiply it times 0, I'm going to get a product of 0. I could pick a number like 26 and multiply it times 0. And guess what? I'm still going to get an answer of 0. So that is our 0 property. Okay, let's talk about the distributive one. The distributive one seems to be the one that kind of gives us the most trouble here. So let's talk about this together. And I lost my notes here. So the distributive property states that multiplying a sum, and you may be thinking, what? A sum is for addition, and we're multiplying right now. So let's think about how this plays together. Multiplying a sum by a number is the same as multiplying each number added and then adding the products. And I'm not going to lie, the first time I read that definition, I was like, what the heck is that talking about? So let's do an example and I'll break it down for us. So the first part says multiplying a sum by a number. So this is what this would look like. Let's say I start with the number 2, and I'm going to multiply it by 3 times 4. Oh, sorry, 3 plus 4. Okay, so here's my multiplication, and I'm going to multiply the sum of 3 plus 4. The distributive property states that solving this based off our order of operations would give us the same answer as if I took each addend and multiplied it and then added the products together. Okay, so 2 times parentheses 3 plus 4 should give me the same answer as doing 2 times 3 plus 2 times 4. And I'm going to solve this so we can prove that this is correct. So if I was going to solve order of operations, on the left side, 3 plus 4 would give me 7, times 2 would give me a final answer of 14. Now, so the distributive property says that if I complete 2 times 3 plus 2 times 4, that I also should get an answer of 14. So let's check. My first step of 2 times 3 would give me 6, plus 2 times 4 would give me 8. My final step of 6 plus 8, sure enough, gives me 14. Okay, so all I did was, again, we took the sum and we multiplied each addend by that number on the outside. I'm going to show us a different way that we could see this. Let's say I start with the number 3 on the outside, and I'm going to multiply it by the number 18. Okay, you may be thinking, Ms. Smith, you said that there had to be a sum here, and there's not a plus sign here like there used to be. So let's look at how they would break something like this down. So distributive property says multiplying a sum by a number is the same as multiplying each number addend. So I just need to come up with 2 addends that create the number 18. So I could start with 3 times 10. And I would need to add to it, if I have 10 there, the other missing part of 18 would be the number 8. So I would need to do 3 times 8. Okay, distributive property is typically the most challenging one. So my hint to you guys is you will know that it is the distributive property if you see multiplication and addition in the same problem. Okay, kind of takes everything we're doing and combines it into one property.